Hello. I'm going to go through number 6 on the Kuta worksheet. This is kind of a wild one. If you look at it, it's x equals in terms of y, which is pretty entertaining. If you don't know how to graph those things, I got two ways to show you this, which is kind of cool. If you want to do it, you could solve both equations for y and just plot them like you would normally. Or if you have access to Desmos, which all of you do because you're in your Chromebooks, you can actually type in equations x in terms of y, and Desmos will graph them for you. So you should get this shape right here, which is really cool. So yeah, all right, let's figure this out. We have to rotate this thing around a x equals 1. So x equals 1 is somewhere over here. I'm going to graph that as well. And we're going to try to rotate this region around here. Now, our shell method would be great for this, but we only have washer and disk. So I think it's pretty obvious to tell that it's going to be a washer method because everything is based off of the axis of rotation. So if I was going from the axis of rotation all the way out to the red graph, that would be a certain length for the radius, and we'd rotate everything from 0 to 4. So that would give us all of this stuff right here, following this little curved path, every little bit of it. So we'd have way too much stuff, and we'd basically have what would kind of look like, I guess, like a solid like a vase filled with, I don't know, cement. All right. The next thing we'd have to do is, again, clearly a washer method, because that's all the stuff that we want plus the stuff we don't. From the axis of rotation to the blue graph is all the stuff that we don't want. So that would be subtracting out to get that hole to make the washer. Alrighty. So we got this picture up here. I'm going to start doing stuff on the whiteboard. But basically, in terms of setting up the integral, I think I can just leave this visual up and we can talk about outer versus inner. So my V out is going to be pi r squared h, as always. And pi doesn't change, but my radius will. So I'll go back to the mouse. You guys can see this. I am going from 1 all the way over to this x value on the red graph. So how do I represent that length? Well, I know from the y-axis all the way out to some random x value on this red graph would be x units long. And I do know that from here to here is 1 unit long. So therefore the distance between the green and the red is going to be all of x. All right, I'll just pick that point right there. All of x minus 1. So my initial radius would be x minus 1 squared. And my slice would be, it is horizontal. If you didn't catch that, I'm drawing horizontal radii. All right, so the height of this cylinder is delta y. My V in is going to be also pi r squared h. It's going to be pi. And then here's my radius. It's going to be from 1 all the way to the blue graph. Well, let's see if we can figure this out. If I go from the y-axis all the way to this blue point right there, I'll put it right in the middle. So from here all the way to here is some random x distance. From here to here is 1. So this is going to be also x minus 1. Okay. However, my color matches for the blue. I'm talking about two different x values, so I'll give you a little, when you get to switch to the whiteboard, I'll make that into red. All right. You could use subscripts if you wanted to. It doesn't really matter. All right, so that's my equations happening here. Again, horizontal slice. So my height of my cylinder is delta y. I'm going to switch over to the viewer. And to kind of go along with what I was just talking about, we were talking about the outer slice was this x value that went from the y-axis all the way out to the red graph, subtract 1. This was the x value that went all the way from the y-axis to the blue graph, subtract 1. and then we had functions given to us on the Kuta sheet that I typed in that were these. So the red graph you can see is radical y plus 3. So when I write these out, I'm going to switch colors here so we're not to get confused. It's going to be the subtraction of these things, but I'm going to clean a little bit first. My v out is going to be pi, and then I'm going to substitute in the red x, which is radical y plus 3 minus 1 squared delta y. My v in, pi, and then the blue y was 1/2 y plus 3 minus 1 squared delta y. Okay, so I don't think I need Desmos anymore. So let's go over to this guy right here, and let's see if we can figure this out. I think we should clean this up before we move any further. We have a pi. I've got radical y plus 2 squared delta y. Right here I've got a pi. I've got 3 minus 1, which is 2, half y plus 2 squared delta y. Okay, so my actual volume will be the subtraction of these things. So that is going to be pi. I'm going to sum all of the slices that I rotated, all the cylindrical slices. So here we go. Actually, cylindrical washers, I should say, because we are subtracting those things. And then I've got to do the outer minus the inner in terms of the radii. So here we go. And then dy. And then now the only thing I forgot on the Desmos was when these graphs actually equal each other. So hopefully this doesn't freeze on me. There we go. It's looking like I'm going from y equals 0 to y equals 4. So the y's are going from 0 all the way up to 4. And again, this Kuta is fantastic stuff because it just gives you practice problems. So you can always have the answers. You'll know if you're right. But that is the setup for it. If you want to see me finish this off, that's fine. I got radical y times radical y, which is y. I've got radical y times 2 plus another radical y times 2, which is 2 radical y plus 2 radical y, which is 4 radical y plus 4. I've got a minus. 2 times 2 is 4. 2 times a half y is y. 2 times another half y is another y. So, yeah, we're going to get 2y. Let's see, what am I missing? 1/4 y squared. And then all of that times dy. So again, I'm going to do a little bit of cleaning here because I'd rather not have all these miscellaneous terms to deal with. Oop, you guys can't see anything. There we go. So here's the gist. Let's see what we can do. I got 4 minus 4, which is 0. I've got y minus 2y, which is negative y. All right, and then so let's see, y's are gone, 4's are gone. And then I've got this guy right here. So I'm going to have a 4 y to the 1/2. And I'm going to have a minus 1/4 y squared dy. And then I think we're in business. We just got to integrate. So hopefully I can squeeze this on this paper. I have negative 1/2 y squared. What's that going to be? 3/2. So plus 8/3 y to the 3/2. What am I doing here? Oh, yeah. Let's see. Minus a 12th y cubed from 0 to 4. And if you want the slickest way to evaluate that ever, you have Desmos already opened. Maybe. Maybe. Oh, we're frozen. Oh, there we go. Cool. So here we go. Negative 1 divided by 2. Okay. And then now I have to throw in a 4 and square it. 4. And then this is the best part. You can use the caret. So shift 6 plus 8/3. It's also going to be nice. I've got 8 divided by 3. And then I've got to do y to the 3 halves. That's 4 raised to the 3 halves. All right, all fractional exponents is great. You do have to arrow down to hit that to get it back on the original line. And I got to type in our 4 cubed. Hopefully I didn't make any mistakes. And now I'm not going to put in the 0 because I do know that I have everything with a y in it would 0 out. Times pi is still 0. So it looks like my answer right here is given to us as 8. So therefore my answer to my overall integral is going to be 8 pi units cubed. Now we'll go over decimals. We'll check to see if that actually is right, or not decimals. What is it called? Kuta? Kuta number 6. Go slow. And let's see, did we get 8 pi? 8 pi! Yay! Right there. Go me. Alright, peace out. Enjoy your week.